Hi everybody, welcome to Lecture 6 for Computer Science 4304 or 6934, Data Visualization. In this lecture, we're going to talk about our first plotting library. So we're going to talk about Matplotlib. So far in the course, we've discussed about Jupyter Notebooks, which is the environment that we're going to use to do all the work in this course, as well as the Pandas data manipulation library. So Pandas is our Swiss Army knife Python library for handling all the things related to our data. It's what we're going to use to load data into a Python environment inside a Jupyter Notebook, as well as access the data once you've loaded it, be able to access subsets of the data, as well as apply some transformations and do manipulation of our data. So let's get into it. So data, right? I've said this before. To create data visualizations, you first need data. Obvious, but true. So now that we have our knowledge of how to access data using pandas, right, loading data, manipulating data, now we can start doing some interesting things with it, like creating data visualizations. And this is where the real fun starts coming in. So data visualization is an exercise in storytelling. And you're going to hear me repeat this multiple times throughout the course. It's an exercise in telling a story. You have a story that you want to tell about the data that you have, and creating a visualization is a way to bring that to life, right? So your data, I guarantee you there are interesting stories that are embedded in your data, and that may not necessarily be clear just by looking at the raw data alone. So if you were to look at the data loaded into a pandas data frame and you have your columns across the top, and you have all the rows of your data, trying to look through the raw numbers or the raw strings or dates embedded in your data, it's going to be really hard to try to find what are the patterns, what are the stories that you want to tell or that should be told. And this is where data visualization comes in, because you can really then bring those stories that are in your data to life and share them with someone else. So I want to present an example, because we haven't looked at enough visualizations, I feel, so far in the course. So for example, there is a catalog of all of the artificial space objects that have ever been put into space around Earth. These are things like basically satellites, all the satellites that have ever been put into space around Earth. And this is just a public data set, right? It contains the full satellite database of everything that's ever been put in. If we take a quick look, we can scroll down. There's a bunch of different catalogs here, but let's just take a quick look at one of them. And here we just have, like a table of information, right? We have our column names across the top, each row of information. Each row is a satellite. We can see when it was launched, right? So there's everything here from the late 1950s when the space race began. You can see all the names of all these different objects that were put into space. The owner, the state. So the state is like the Soviet Union, the US. That's all you see at the start, right? That's the start of the space race. You see JPL is Jet Propulsion Laboratory in the US. We have all sorts of information about the satellite itself, like what was the mass of the satellite, its length, its diameter, its span, which can, some things may unfold like solar panels and have a much larger span, the shape of the object, whether it's cylindrical or spherical, and all sorts of other information in here, right? And so there's all sorts of stories in this, right? Just to mention, like you can see the Soviet Union, the US, that space race in the late 50s going to the 60s. And there's a lot of information here, right? If you just scroll down, right, and this goes on and on and on forever, there's about 50,000 rows in this data set. And this is the stuff that, launched this month, right? September 2021. You see things like Starlink, which is space internet. So there's a whole bunch of stuff in here about Starlink, Dragon capsule. We can find things like if we do a search for Mars. Let's go to a more recent one. Mars, box, two-wheel antenna, Mars 2020 rover, Perseverance. right? So we can find, you can find like Perseverance in the Mars 2020 rover. And Perseverance has been doing really cool stuff on Mars. Right? They have a little helicopter that they sent with it that they, are controlling remote. They're doing remote control on that helicopter from Earth and having it fly around Mars and do all sorts of interesting exploration. Right. So there's all sorts, like, you could have a history of all the Mars rovers and all the Mars satellites that have been sent. There are so many stories embedded in here, but to find them is really, really hard. It's really hard to work with this with the raw data itself. And so what I want to show is this infographic, which has all of the active satellites around Earth. So this is made by Nadi Bremer. She is a freelance data visualization designer and artist. She works near Amsterdam, and she does some really interesting stuff. So she has all sorts of like interesting visualizations here. Let's take a look at this one. Right, it's called Space Wars. So I created a visualization of all the satellites that are still active in space. Let's just take a look at this and zoom in, because this is a really interesting visualization because there's a lot of information here. So let's just start off and read her description. Much of space is vast and empty. The portion near Earth is not. There are lots of satellites clogging the space around our planet. The spacecrafts are used for communications, imaging, research, GPS, weather forecasts, all sorts of different things. One even carries humans. That's the International Space Station. So this chart shows each of the thousands of active satellites, as well as their owners, where they are, and what they do. So there's a lot of information here. Right, and you can see, like, so each of these points is a satellite. She provides a how to read the chart. Each of the 3,000 dots below represents an active satellite, as recorded in the catalog that we were just looking at. The dots are organized by controlling region, which are the columns, and the orbital type, which are the rows. So we can see here is the US, right? Here are all the US satellites. Europe, all the European satellites, all the Chinese satellites, Russian, Japanese, Indian, everywhere else. And then they're organized horizontally this way. So this is low Earth orbit satellites all along here between these two white lines. We have medium Earth orbit satellites, geosynchronous orbits, and then any other kind of orbit, which can be like highly elliptical orbits or just some obscure, like really, really strange or unique orbit. So let's read about this a little bit more, right? The dot size represents the mass of the satellite. So larger dots are bigger satellites. Everything is organized into a class and category. The color represents the category. So purple are communications satellites. Green are imaging, surveillance, meteorology. Red is navigation. Blue is research, or like science, basically. The symbol includes a class. So some of them have a symbol written over them. If they don't have a symbol, it's a business or commercial, which means it's basically like a private company. And you also have things like defense, which are these pointed arrows. And straight from the beginning, right from this broad overview, you can already see a lot of patterns coming out of it. Right, if you look at the low Earth orbit satellites, you can see these dot sizes are much smaller than most of the satellites in geosynchronous orbit. Right, geosynchronous orbit satellites are larger than low Earth orbit satellites. There are some exceptions to that, of course. Right, just looking at the US, you can see some of them are larger. Some of them are actually quite large, but you can tell from the symbol inside of them that these are all defense satellites. Right, all these large ones are basically all defense satellites. And she's actually highlighted a couple of them and named them, right? So this yellow one here is X-37B OTV-6. Who knows what that's doing, but it's doing something defense related up there. You can see this larger blue one here, right? That's a research satellite, Hubble Space Telescope. You can also see some interesting comparisons between the different regions, right? All of these, well, right, you can see for the US, there are a lot of imaging, surveillance, and like meteorological satellites in geosynchronous orbit compared to the other regions. China, most of their low Earth orbit satellites are imaging, surveillance, and meteorological. Very few communication satellites, very few purple. And you can see even all of these communication satellites that the US has sent up, the vast majority of them, right, they don't have a symbol over them, so they're just sent up by private companies or private businesses. And so from all of this, right, you get we've already identified several patterns in just the space of a couple of minutes. If you had looked at the raw data and tried to read these patterns from that, it would have been incredibly, incredibly hard or near impossible to do so. But this is why you create a visualization, because you can just see all those patterns immediately, just jump straight out at you. All this information is just here at your fingertips, and you can just see that all very, very quickly. Right? Data visualizations brings the stories of your data to life. So we're going to use Matplotlib in this course. Matplotlib is a comprehensive library for creating static, animated, and interactive visualizations in Python. And what's important here is that it's a comprehensive library. Right? So Matplotlib, it's a Python plotting library. It was originally designed to emulate MATLAB style graphics commands. So MATLAB is sort of a programming, it's a language in itself, but it's also like a programming environment in which you can, that's commonly used for doing all sorts of scientific or mathematic analysis, which is where it gets its name MATLAB, or like mathematics lab. So a number of API elements in Matplotlib are sort of derived, or they are, they resemble MATLAB style commands. That's because it has this history of, it originated from MATLAB. It was basically a Python port in some ways of MATLAB style graphics commands. And because of that history, that tie to MATLAB, Matplotlib is used extensively for scientific and mathematical plotting, which is why we're going to focus on Matplotlib in this course, because we're looking at data visualization through the lens of data science, right? Because at the heart of data visualization, we're not just trying to create pretty graphics, we're trying to visualize data that we have. And that data can come from many different sources, and there's definitely an artistic license to how you present that data. But at its heart, usually that data is going to be, you've done some sort of like mathematical or scientific work with that data to either achieve it, either to create it, extract it, or collect it. But it also includes, the analysis you may have done to that data to create, to find the interesting stories that are embedded in it. So here I'm showing basically an overview of the visualization ecosystem in Python, because Matplotlib is not the only visualization library for Python. There are many, many libraries out there, and they can be sort of grouped into 3 or 4 main families of libraries. So you can see Matplotlib is at the center of one family, JavaScript at another, D3 is another very popular plotting library, and then OpenGL, which is basically a way to render directly using graphics cards hardware. So Matplotlib, there are a number of libraries that use Matplotlib as its base, because Matplotlib is a very comprehensive library. There are a number of libraries that try to basically extend Matplotlib. So we're going to be talking about, one of them is Seaborn, which we're going to talk about in this course as well. You can see Pandas is here. Pandas does come with some basic plotting functionality, which uses Matplotlib as its backend. You can also see scikit-plot. We're not going to be talking about scikit-learn in this class, but scikit-learn is a very popular library for doing machine learning related tasks. We're not going to be touching machine learning in this course, but it can often, part of data science is doing machine learning. So scikit-learn is very popular as well, and that also uses Matplotlib. One of the nice things is when all these things are using Matplotlib together, you can often use them interchangeably, or you can work with them. They have some ability to work together, which can be very nice. And we'll definitely see that when we start talking about the Seaborn library. Over here in JavaScript, there are a number of Python libraries that are built on JavaScript. So JavaScript is basically a language for doing front-end web development. We are going to be talking about the Plotly library in this course. So Plotly uses JavaScript. It's entirely different. The way it creates plots is entirely different compared to anything that's using Matplotlib, right? It's based off JavaScript, where all these things are based off Matplotlib. We won't spend a lot of time talking about Plotly, but we're going to spend a little bit just to introduce it, just to show basically the variety of visualization tools. But in general, anything that you want to do in Plotly, you could do with Matplotlib. There's just some small differences in terms of the API or how you create a plot using it. You can see D3 here. D3 is previous years of this course have introduced D3. You can see that it is based on JavaScript, right? So D3 uses JavaScript. And so D3 is in many ways the language of creating visualizations for the web, because you can just create a D3 visualization. It's in JavaScript, and then you can put that JavaScript onto a web page somewhere, and you can create some really interesting visualizations from there. We are going to stick with Matplotlib just because I think this is a better library for doing specifically data visualization. D3 is great if you want to create visualizations, specifically web visualizations, and you can certainly create data visualizations in D3. But Matplotlib and its libraries will give you a bunch of tools that are perhaps a little bit better suited towards specifically data visualization and not just general visualizations. D3 is extremely, extremely general in terms of what kind of visualization you're trying to make. And then over here we have OpenGL, right? And there's several different libraries that use OpenGL. And OpenGL is, you can write OpenGL code directly if you want to. You could write C code or C++ code or other languages to access the OpenGL libraries. And as you can see, right, they're only very tangentially related to any other libraries here. Right, you can see there's a strong connection between the families in JavaScript and D3, and then you can get some connections from this into the Matplotlib. Like, this is all very strongly connected, whereas OpenGL really stands off on its own because it's just so different. And then you also have some other things that are just sort of off on its own. PyQt, or I believe it may be pronounced PyQt, right? Qt is a library for creating user interfaces. So yeah, I just want to provide this broad overview of, we're going to be working with Matplotlib and Seaborn, and we will touch on Plotly, but there are a ton of other libraries out there, and many of these are extremely good. Okay, so Matplotlib, right? Matplotlib gives the user complete control over every component of its plot. That is Matplotlib's strength. And its goal, as stated on its website, is that Matplotlib makes easy things easy and hard things possible. Because you have complete control over every component of your plot, it makes it possible to do some really hard things. Right? So there's a pro and a con to this. The pro is that every component is customizable. If you have a plot and you want it to look a certain way, Matplotlib will give you the ability to do that. Every component you can access and redesign however you like. So you can make a plot that, and we will see this in this lecture, right? When you just do like basic Matplotlib functionality, it gives you like a standard default looking plot. You can customize that to make it look completely different, however you like. The downside of all of this control and customizability and the comprehensiveness of Matplotlib is that making a decent plot might take a lot of effort, because you might have to then specify and put a lot of work into every single detail of your plot. And that's sort of where all of these other libraries that extend Matplotlib come into. Specifically Seaborn, which I'm much more familiar with than some of these other ones. Seaborn is a way of trying to handle some of that customizability for you, so that it can make easy plots that also look extremely good. So yeah, pro and con, right? Matplotlib, everything is customizable, you have complete control, but the con is that it might take a lot of effort if you want to apply all those customizations. So let's first start off with just very basic terminology of what a plot is. Just to ground, make sure we're all on the same level about what we're talking about when we're talking about a plot. So here is a plot, shows workload through the term. We can see here is your workload measured in some units of whatever, versus the lecture number. You can see, right, lecture 1, 2, 3, your workload is quite low. As the term continues on, your workload continues to increase. Perhaps this could have been labeled stress level instead. Your stress level continues to rise as you get later into the term, and your workload increases too. But there's a number of elements here that I want to talk about. So just to point out, there's a number of annotations on this plot. So we have our title, right? Just the title of the plot, the workload through the term. We have a legend, which tells us, right, we have a line here. We have a line plot. We have a legend that specifies, what this line is. We can have labels for our y-axis and our x-axis to tell us, this y-axis is workload, x-axis is the lecture number. But there are also a few other elements to this plot. So for example, we have our x-axis ticks, our y-axis ticks, and our x-axis ticks. And our ticks are these little black lines that come off of our plot here. It's not the number, it's this actual little line. The numbers here, right, 80, 60, 40, 20, these are the labels for the tick mark itself. So you might have actually major tick marks and minor tick marks. So you might have a larger mark here with smaller marks in between before you get to the next large mark, similar to what you might see on a ruler, right? A ruler will have 1 centimeter mark, and the millimeters are smaller than large centimeter, smaller millimeters. You can have that there. You might also have grid lines on the background, and even things like, just this box itself, the box containing our plot. That's a component. And all of these components can be customized with Matplotlib. And of course, the actual plot, right, that you've made, right, this line here, or this curve, that is completely customizable through Matplotlib as well. So that's the anatomy of a plot. But let's talk about a Matplotlib plot. So Matplotlib has two key concepts. One is the figure, and the second is the axes. So a figure, it constitutes everything in your plot. Everything that you see is contained in your figure, right? Everything that you see here is inside. If this was a Matplotlib plot, everything here is contained in the Matplotlib figure. An axis is a part of a figure. So a figure is like the container for everything, and the axis is contained inside that figure, and the axis is what actually holds the plot itself. So the axis contains the plot, contains the labels, it contains the tick marks. Every other plot element is inside the axis. And so you'll see this much more clearly when we start looking at some Matplotlib code examples. But the figure is everything, and the axis is a plot that's contained inside the figure. So why is there this distinction? Because some figures may contain multiple plots, right? You might have two plots side by side. That would be two axes side by side, and they're contained in one large figure object. Okay? So a figure is everything, and the axes is a specific plot inside that figure, because you might have multiple plots, for example. And so Matplotlib also offers two different interfaces to create plots. One is its functional interface, which is a set of global functions that are called directly from the library. And these will create and manage the figure and axes when you're plotting. They will just manage all of that for you. So we're going to start off by looking at the functional interface, because it's a little bit, it's a small amount easier than looking at Matplotlib's object-oriented interface. It's a good way to just understand the concepts of what Matplotlib considers to be a figure and an axis. Matplotlib's object-oriented interface explicitly creates these figure and axis objects, and then you call methods on the objects to make your plots. So functionally, well, at the end of the day, you can do exactly the same thing in your functional interface that you can in your object-oriented interface. They have almost exactly the same functions or the same functionality between them. It's just the functional interface, it's a set of global functions. So you're just calling global functions from the library. The object-oriented interface is you're creating the figure and axes objects. You have a figure object, you have axes objects, and you work with those, and you call methods on those objects to make all the plots and all the different customizations and elements of your plot that you want. Okay, so in this lecture, we're going to start off by just looking at a very simple functional interface example of how to create a plot in Matplotlib. So let's switch over here to our Jupyter Notebook. Let's make this a little bit bigger for everybody. We have lecture 6. Yes. Just restart clear output. So lecture 6. So we're going to look at the Matplotlib Python plotting library. Matplotlib is a comprehensive plotting library that gives you control over all aspects of your plots, and there are many other libraries based on Matplotlib, as we have already talked about. So our learning objectives in this notebook are to introduce Matplotlib's functional plotting interface. Next lecture, we will talk about its object-oriented interface. Here's a link to the Matplotlib API. You can easily just Google that. First things first, we're going to load our Matplotlib library. So Matplotlib comes with many submodules, but the one that we really want to focus on, and that really is the main workhorse of all of things from Matplotlib, is its PyPlot submodule. That contains all the plotting functionality that we're going to use. So the PyPlot submodule is almost universally loaded with the shorthand name of PLT. Just as pandas is almost universally loaded as PD, matplotlib.pyplot is loaded as PLT. So I strongly recommend that this convention be adopted by you, because this is just how everybody does it. And you don't want to be typing out matplotlib.pyplot every time you want to use it. It's nice to shorten that to just PLT. So let's run that. So let's load some data. So for this lecture, we're going to continue working with the data set of trending YouTube videos. So we have our data frame here. We're going to read in this CSV, CA videos.csv. As we've talked about in previous lectures, if there's date time information in our data set, we can just tell pandas to parse those columns as date time objects. So we've loaded our data set. And then because this data set is quite large, there's about 40,000 rows, we're going to try to restrict that to a smaller data set just as we work through our introduction to Matplotlib. So let's work with a smaller data set just to keep things clear. So as we did before, and as we've looked at this already, we're going to look at just videos that were published by Marvel Entertainment, right? So DF filtering where the channel title equals Marvel Entertainment. So let's run that. And then if we look at our data frame, right, we can see channel title Marvel Entertainment, and we can see all the different videos that were published on Marvel Entertainment going down. Okay, so some basic plotting. Matplotlib's fundamental way to plot something is by calling plot.plot. So we're just calling a global function from the library, right? Our library's PLT. We're just calling this global function plot. And you just pass it your X data and your Y data. Like the values, like you have your data will have an X value and a Y value. So we're going to plot the number of likes, the comment count on the Y-axis versus the number of likes on the X-axis. So we're just going to just define, just take this column likes, just put it into X, put it into some variable Y, and then plot X and Y. And just like that, we've made our first plot. You can see here's the number of likes across the X-axis, right? So there's up to 3 million likes for the largest video, about 350,000 comments. And you can see that's a pretty linear relationship, right? As the number of likes increase, so does the number of comments. And it's pretty at a pretty constant ratio. And again, I think this just shows, the power of creating a visualization. If we wanted to try to see this relationship here, right, this sort of constant ratio of a relationship, we could take a look at our data. This is likes, this is comments, I believe. Let's scroll up, make sure. Sorry, dislikes. Likes, comments, right? So 70,000, 1,300. 20,000, 3,400. Right? We can scroll through this and try to get a sense of, this relationship, but it's much harder to do than just looking at this figure because it just pops right out at you. Just immediately you see that. And so there are a number of additional arguments that plot takes. So for example, we can change the color of our line by just using the argument color. And Matplotlib is pretty good in the sense that you can just give it a string of the color name that you want, and it will figure out what that color is. So we can say plot.plot, right? X, Y, we're going to say color equals red, and we get a plot with a red line. We could do blue as we did before. We could do black, any number of colors. Additionally, we can also specify this as RGB value. So we could say like red. Red is maximum, 0 blue, or 0 green, 0 blue. We get red. If we want a darker red, we could do this. If we want to have, say, purple, right? Red, green, blue, a little bit of red, a little bit of blue gives us purple. So you can specify whatever color you like using RGB values. And if you want to just do something very simple, you can just type out the name of the color that you like. Some other options, if we want to, tweak the style of our line here, we can specify the line width, which is the thickness of our line. And we can also specify the line style, which is like right now it's a solid line, but we could change that to a dashed line if we want to. We could change that to a dotted line, a dot dash line. There's several different options. So let's just show we can do line width equals 5, and we can specify a dashed line. So we're going to specify line width equals 5. So we have a nice thick line compared to before. And our line style, it takes these arguments. So if we just have just a hyphen by itself, that means a solid line. If we have 2 hyphens, 2 dashes, we get a dashed line. If we get a hyphen and a dot, we get a dot dashed line. So there's a few different options that are available. I think we can do dash dash dot. No. Can we do dot dot dash dot dot? No. Well, there's definitely a few other options on there. Right, and this can be useful like if you have a particular line style that you want to use, or if you have a line that you really want to emphasize, you can make it thicker. Or if it's too thick, you can make it thinner if you like. So we can make this like a really thin line. All right, so our plot here, like it looks a little bit bare. We have our line. Let me just make this, here we go. So we have our line, but our plot looks a little bit bare, right? Matplotlib has taken care of putting out the tick marks for us. It's chosen sensible tick marks. and it's put labels on those tick marks, so 0, 1, 2, so on. And here again, right, sensible tick marks, and labeled those tick marks for us. But it hasn't labeled any other elements. We don't have a legend, we don't have a title, we don't have a label on our axes. And it's a fundamental responsibility to label your plot correctly, because these are just numbers. Like if I hadn't told you that this was the number of likes and this was the number of comments, you wouldn't know, right? Like you wouldn't know that. If I put this into a report or I submit, if I pass this to somebody else, they wouldn't know what this means because there's no labels to tell them what this is. So at a very simple level, Matplotlib gives you several functions: X label to add a label to your X-axis, Y label to add a label to your Y-axis, and title to add a title to your plot. So we can do, right, plot.plot, we're going to plot X versus Y. We're going to label our X-axis as likes, because that's what it is. The Y-axis is going to be labeled comment count, because that's what it is. And we're going to give our plot a sensible title. So there's a lot of flexibility. You could, the simplest title is saying, I'm plotting X versus Y. But there's a lot of options for how you title a plot. So in this case, I want to call it Trending Marvel Entertainment Videos, because this is just Marvel Entertainment Videos, and it's nice to, annotate that, to show, to explicitly say that this is Marvel Entertainment Videos, specifically trending videos. Right, it's not just any random YouTube video. So we can plot that. And then we can see, right, we've labeled likes here, we've labeled comment count here, we have a nice title on our plot. As well, we can adjust the scale of our axes, right? So like it's chosen a scale for us from 0 to, just shy of 3 million. And here from 0 to, 350,000. So it's chosen axes scales just for us by default that span the range of our data, which is generally what you want to do. But if you want to be more explicit, you can also specify these values by saying xlim and ylim. Each of these functions takes a tuple, right? So a tuple is just two values, right, inside brackets. And the tuple is the lower bound and the upper bound for the range of your axes here. So for example, what we might want to do is the number of likes here is 3 million. The number of comments is, like, the scale of these are different from each other. So our plot, in some sense, we just have a straight line. It looks like a 45-degree straight line, right? It looks like a 45-degree straight line, but it's not, and it's not because the comment scale here, right? The comment count is only about 1/10 as large as the like scale. So if we want to, we can specify them, put them on the same scale. So we can say, right, let's just get rid of this for a second. We have, right, making a plot, we're adding an X label, a Y label, a title. We're going to add limits. We're going to say our X label, our X limits, takes a tuple. I say it's from 0 to 3 million. And our Y limits are going to be 0 to 3 million. So they're consistent. Not 3.6, 3 exponent 6. Here we go. And now you can see, like, it's a different story, right? We have the X-axis range here for the likes is more or less the same. It's a little bit different from previous, but more or less the same. Our comment count now extends all the way to 3 million. Right? No video has that many comments, but you can see that, like, the ratio here is much more clear. Right? You could look at this and see that, oh, for 2.5 million 2.5 million likes, we're only this high on the comments. And so even though, like, you didn't even have to look at the numbers to know this, right? If these numbers weren't even here, but you knew that they were the same scale, you could approximate this as, 20%, because it's 20% of the height, or say 10-15% of the height. Whereas here, you have to look at the numbers to understand this, right? It's just a visual a small visual thing. So using the X limits and Y limits, you could also zoom in on a section, for example. Like if we really wanted to look at the behavior on the low end, we could restrict our X limits and our Y limits to just in this region. So let's look at our X limits. We're going to look up to 500,000 and up to 50,000 comments. Right, so we really zoom in on this low end here, and we can see there's a bunch of jaggedness to it. Okay. If you want to plot multiple lines using Matplotlib, it's very easy. It's very straightforward. Just call plot a second time. So if we want to plot the number of comments per number of likes, and also show the number of dislikes versus the number of likes, right? So previously we have, we just have this plot here. If we want to add this extra information, we just make a second call to plot. So if we want to plot dislikes versus likes, we can just call plot a second time, and we'll just add that second line in for us. Right? Very, very easy. If we want to add some labels, well, right now we don't have a legend, so we don't know which line is which. If we want to add a legend to our plot, we can just let's just take our section of code here. If we do, we can say the label for this line, or like the name of this line, is going to be comment count, and the label or the name for this line is going to be dislikes. And then all we have to do is plot.legend, and we'll create the legend for us. So then we can clearly see that the blue line is the number of comments, and the yellow line, or this orange line, is the number of dislikes. All right, and so that's an important element of annotating or labeling your plot correctly. So you know which line is which. All right, and then finally, if you want to save your plot to file. So right now, this is showing up just in the Jupyter Notebook environment. Right, we have our plot here. It displays it immediately for us. And this again shows the value of a Jupyter Notebook is that I can make my plot, and it's displayed, almost in line with the code that I've used to create it. And I can very easily, tweak this and see, see any changes that I've made to it. But sometimes you'll want to save your plot to file because you'll either want to put that into a report or put that into a set of PowerPoint slides, or even just post it onto Twitter or some other social media, or send it to your friend, or, do something. You want to share that in some way. And it can be, it's not always appropriate to share that inside of a Jupyter Notebook. So Matplotlib, you can just call savefig, right? There's a savefig function. And Matplotlib can save to many different file types. So we can save it to JPEG, PNG, PDFs, PostScript, SVG, potentially a few more, but those are the main ones that you'd probably want to use. So if we want to take our plot here, and let's just add in our legend for this too. Right, so we have our plot here. All we do at the end is just call plot savefig, and we just give it a file name. So we can just call this my first plot. Let's save it as a PNG. And when we call that, so it will print out, like it will output or display the plot that we've made. If we go back to our file system view, we can see our plot is here. Right, my first plot made just seconds ago. And then we can open that up, and here it is, right? My first plot.png. And then we can take that file and we can, share it or do whatever we want with it. If you look at this, you might notice something that looks a little bit off. So over here, right, what do we have? We have trending Marvel entertainment videos. We have our comment count versus the number of likes. We have our legend here that tells us this is the number of dislikes and the number of comments per the number of likes. If we go back to our plot, what do we see? Does everything look fine? You see our trending Marvel Entertainment videos, number of likes, number of comments. Our number of comments, our label here, has been cut off. So this is one of the small gotchas when you're trying to export your plot to file, is that here, everything can look fine, but when you save that to file, the canvas that you save it on, so like there's some, just generally speaking, you have like a canvas that you're making your image on, that might not permit all the elements to fit onto it. So a very simple thing to do, because this is, I guess, quite common, Matplotlib gives you a function that deals with this problem directly. So if you just call tight layout, it will readjust the plot so that all the elements will be correctly, they will fit onto the canvas and they will display correctly when you save it to file. So we can take our code that we have here. Let's take this, we'll just copy this. Right, same code as before. And we're just going to call a plot.tightLayout. Right, here it looks more or less the same, looks basically the same as before. When we go to our file, now everything is correctly displayed. Everything fits into our image correctly. So it just readjusts the size, basically it readjusts the size of this box just to make sure there's enough room for the label that we've added and all the other elements. So it's often a good call just to call tight layout before you save this to file. And then you can start to see, like, we've just made a very, very basic plot. Like, Matplotlib has given us the functionality to, create the legend, create the colors, the width of the line, put all these labels, the X limits, Y limits. We've had the ability to customize this plot however we like. We could say that this is a sort of a darkish red line. We can make this line a darkish blue line. Right, we have a darkish red line, darkish blue line. We can set our label. We can specify this one as a solid line and this one as a dashed line. We can make this one a little bit thicker. Line width equals 5. All right, so we get, like, here's a solid line. That looks kind of ugly in my view, so let's make them similar thickness. Make this 4, make this 4. Right? So we have the ability to control all these elements. But you can start to see that our code to create this plot, even though it's a relatively simple plot, is starting to get a little bit long. In my view, it's a little bit long because you have to specify the plot with all these arguments for each line. We have to manually specify the labels, specify the titles, manually create the legend, then create, and then this extra little bit of code to try to save it to file. And so we've only just scratched the surface on the customizability with Matplotlib. And so if we want to keep going with this, we're going to end up having a lot of extra code. But it gives you that's what Matplotlib offers. It offers this comprehensive library to be able to change all of these things and access all of these things to customize them. All right, so we're going to finish there. Next lecture, we will continue with Matplotlib. So far, we've just been using the functional interface, which is just calling all of these functions here directly from the library. So these are just global functions that we're calling. And we haven't had to worry about figures or axes because it's taking care of all of that for us behind the scenes. Next time, we're going to take a look at its object-oriented interface, in which we create figure objects and axes objects. And we'll discuss the pros and cons of that approach compared to this approach and see how the two compare. All right, thanks everybody. See you next lecture.